Now, Excel is great for having students examine functions, both linear and nonlinear functions. And it's also great for having to plot points and see how the line goes perfectly through them. But oftentimes, students aren't going to get perfect data. They're going to get real-world data that doesn't necessarily fit anything perfectly. And so they have to actually start looking at the regression lines. So here's data that happens to be that our height and our weight. And I can highlight our data. In this case, I've got it in 2 rows versus in columns. And if I want to do a scatter plot, I've got my height and my weights here. And I can look and say that's not necessarily fitting the way that I would expect. So I can try adding trend lines and see what happens. And display the equation and my r-squared values. And my r-squared is not my correlation. It's actually the squared value of my correlation. So it's not necessarily telling me information about the correlation itself. But say I'm looking at my trend line here. I want to say, and we can use the r-squared just to give us a general reference. I can click on the different values and say, is there a value that seems to be giving me a stronger r-squared? And then I can look at the correlation. And if I look through here, there does seem to be a little bit more strength if I use a curve versus using the straight line. But in this case, we're going to stay with the straight line to discuss correlations. So if I leave it as a line, again, r-squared is not the value that represents the correlation. And we only talk about correlation if we're looking at linear relationships. What I want to do is take the square root. So equals SQRT, and it's 0.6138. And this is an approximation because this value is an approximation. So about 78 hundredths. Now Excel will find a correlation for me if I use the formula CORREL. And I can highlight my x's, comma, highlight my y's. And you can see they come out pretty close, but this is more accurate. The other positive to using this value is that correlation can be positive or negative. For instance, if my line actually came down to the right, that's a negative correlation. As one value increases, the other decreases. And if I just use my r-squared value, that's not going to be picked up and I'm going to have to pay attention to that. Now, when I talk about looking at correlations, I want to know, well, how good is this line of fit? In this case, 78 hundredths. Well, if I look, that means that I'm moderate, because I'm between 5/10 and 8/10. Whereas, say this person here that had 222 pounds, maybe they dropped down to 200. All of a sudden, and I can't pay attention to this because I entered this manually, so I'm going to delete it out. All of a sudden, my correlation is now at 84 hundredths. But with that one person losing a little bit of weight, I now have a strong relationship for my correlation to my data. So that's one way I can actually start comparing my data when I'm trying to think about what is the best fit.